Hi, my name is Joseph Cohen. Today I'm going to talk about imaging's potential to assist in the COVID-19 crisis. The first thing I'm going to talk about is the types of models that we can build, either diagnostic or prognostic. So for diagnostic, we want to answer questions such as, does this patient have pneumonia? What's the cause of this pneumonia? The kind of consensus around if we can actually make a diagnosis from chest imaging is that they're non-specific features. And this is compounded with a lot of literature that has flawed evaluations. However, chest imaging can still play a role in triaging patients due to high PCR turnaround times. But the goal that we're going in is prognostic predictions. So they're useful for triaging patients and answering questions such as, should this patient stay home? Will this patient need the ICU in a few days? Can this patient survive at all? Will they respond to a specific treatment, such as intubation or some drug? And answering questions as in, should a tube be removed? Should they be taken off a ventilator now? Are they ready for that? Okay, so the first step to building any of these models is collecting data. We can either release a large data set from hospitals, which appears to be impossible, or we can get data in the form of publications, which is a very common thing for hospitals to do. And they have figures that have chest x-rays in them with a bunch of clinical information about the patient. So what can we do to build a data set is to scrape figures from these publications and combine them together in a data set we can use. So we started this project on February 14th. We now have almost 257 frontal chest x-rays with a with various time points through this patient's course, and some severity indications, whether they survived or whether they were intubated. We also have some CT scans available as well. All right, so the database structure to go over quickly is a CSV file, just for simplicity. And we have different fields, such as an offset, which is whether when they started having symptoms or when they presented at a hospital. The finding they have, yes or no survival, intubation. A lot of these can be blank. View information for the X-ray, right? PA, AP supine. For all these rows, the file name is the unique identifier, and we have information on the specific paper that it came from and some clinical notes that are associated with that image. All right, so some stats about the data set, which I'm not going to go over, but I put this here. All right, one thing when building any of these models is to not claim any diagnostic performance without a clinical study, because this data set is very biased based on how it is actually constructed. So note that when you're evaluating the performance of any model that you train on this data. Moving forward, what you can do, what we're doing, is to scrape more images relating to severity, right? So images that have this kind of severity information associated with them. And you can help. We have a GitHub issues page with papers that we want to add, or in the whole discussion about which new pieces of data to add. Also, what you can do is encourage medical groups to release their own public data sets in their own paper as their own online data set, and then we can aggregate them together. You can also urge them to submit to sites like EuroRad or Radiopedia, which we can very easily scrape and have a license that works well. That's public. It's a Creative Commons non-commercial. Currently, we have a research protocol pending at UDEM for a direct collection or an indirect collection system that people can submit data to us, and then we can include in this data set. For analysis, we're working with hospitals such as the Schumann in Stony Brook to validate models. We don't have any models to validate yet. So what you can do is build models using the cases we have, test them on data at your hospital if you want to do that internally, and I'm happy to chat with you about this. A direction algorithmically for this is to employ transfer learning strategies such as few-shot learning, meta-learning, or metric learning, to make these models that we have already for these large chest X-ray public data sets work with this small number of COVID examples that we have. One tool that you might want to look at is this tool called Chest of the AI Radiology Assistant that we worked on at Mila. It's not for medical use, but you can analyze data with it and see if there's any sort of relationship that then can be validated in some further study. So here's two patients that we pulled from the data set. We said they both predict infiltration. These patients are kind of similar in age, so that they're young, but one survived and one didn't. So looking at links between these existing radiological findings that we could predict. So these are 14 radiological findings from the NIH data set. Great. Also, something to look at is the Torch X-ray Vision library. So it has a bunch of pre-trained models, data loaders for all the major data sets, and a bunch of tools to make these data sets usable and comparable with each other. Great, thank you.